Hello and welcome. You're listening to the podcast at the Crossroads of the SAFE Network, right here at safecrossroads.net. I'm your host, John Ferguson, the simpleton of Project SAFE, because not everybody can be a geek. It's kind of a geeky subject. Most of us aren't geeks. Few of you are. Hopefully we can all talk together about this very interesting subject, the SAFE Network. SAFE stands for Secure Access for Everyone, with privacy, security, and freedom built in from the ground up. It's been a long-term project. MaidSafe has been working on this for over 12 years. It's rolling out in various stages. And, I owe probably some intro episodes, but if you really want to get your own grasp on what this is about, I'm going to tell you, go to safenetwork.tech. Really great site that will kind of let you see what it is and follow your own leads. There's a lot of different angles and aspects to this. You got to kind of follow them in the sequence that you have the questions. And I've found that site is really good at doing it. We'll be covering more breakdowns, looking into different aspects of this as we go forward. We're going to see much more regular podcasts on the SAFE Network. I'm planning every other week to have one, alternated with Technology and Choice, my other podcast, on alternate Wednesdays. So we're going to be doing more regular, and it's made possible in part by MaidSafe, who is a sponsor of this show. Great bunch of people there. And if you're a developer or into networking and so forth, you might want to go to MaidSafe.net. And check out the opportunities if you're looking for a really forward-looking project. It's been a long time in the making. It's coming finally towards getting launched. It's taking a lot longer than any of us hoped. But this is not just an incremental change we're looking at. We're looking at a real basic redesign of how we interact with our data so that it's really private, secure, and free, SAFE. For everyone. That's the E part. I was going to read a post by David Irvine, the founder of MaidSafe and so forth, regarding how to think about the network. But it was a little uncumbersome. But there was one image that I'm going to share that I got from that. I will link it in the show notes. It's like one way of communicating about the SAFE Network. He breaks a lot of different things down. But just think of privacy, security, and freedom from the ground up. And then get this image. You're at home and you decide to go out. You lock the door and everything in your place just turns to dust and flies out the window. And, there he is. And somebody comes along, there's nothing there. Nothing there, nothing to see here. You come back, you put your key in the lock, click, and your stuff reassembles faster than you can see. This is the network at work. You don't have anything on your local computer. You don't need to. You can, of course. But if you log in on any random computer that you consider to be secure in and of itself, you have your whole world right there. Doesn't handle things like keyloggers. That's a problem we all have, and we'll solve that on into the future. But essentially, we're talking about perpetual data. You store it, and it stays there forever. And it materializes out of nothing when you call for it. I likened it to storing things in the mist rather than the cloud. What's this storing in the cloud? Well, basically, you have somebody like Google or Amazon or whoever who's holding your data for you, and server is located somewhere, and you don't necessarily know where, but you're not in complete control of it, but you're trusting them. Well, I like to think of the SAFE Network as storing your stuff in the mist. You store a file, it gets chopped up, it's encrypted by a very special self-encryption process, and it gets spread out in chunks and little meaningless to anybody but you chunks stored all over the world in random and duplicated places so that all you have to do is call them back and your data materializes for you. Anyway, that is a vision that I just wanted to share. And as I say, I'll link that post in the show notes from the forum. Just before we go forward, safenetforum.org is a community forum, incredible place, and you can branch off from there. There's a developer forum and many other aspects, GitHub and so forth, because the MaidSafe project is all open source. It's all being done right out in the open, every step forward. Now, we're going to roll on into the interview here shortly, but to introduce that, I want to talk about an article that MaidSafe put out on October 16th, published it on medium.com. It's called SAFE-Fleming, Our Next Major Milestone. And this is a good setup to give probably pretty much anybody an idea of where we're at and what we're rolling into. Now, MaidSafe has been testing and working and developing the network infrastructure, software infrastructure for a long time. Many tests have been done, some running nodes at home by community members and so forth. And last year in September of 2017, over a year ago, MaidSafe released the Alpha 2 version of the SAFE network. And that was really cool. And it is cool. It's been running ever since, except one little glitch. It had to be reset. Rather than being run from home as the SAFE network ultimately will be, all the nodes for this network were hosted by MaidSafe in the data center in order to provide a stable network that has the key basic functions of the network exposed for developers and users to experience, mainly for developers to be able to develop against and try. How do you work with a serverless architecture? Alpha 2 has continued to run and will for the foreseeable future while the rest of this rolls out. So if you have not gone to the SAFE Network forum and signed up and participated just enough to get up to trust level 1, which doesn't take a lot, get your ticket, check it out. There's some really neat stuff. You'll get to see self-authentication in action. We haven't covered that here, but it's kind of neat. You get to see how your files are stored and spread around the network in chunks that are indecipherable. You get to see, experience how the application protects your credentials so that you can authorize apps to use certain things without them getting access to your credentials. So no rogue app is going to steal your data, and neither can the network do so. Check it out. All right, so we're ready now to roll out what MaidSafe has been working on flat out over that period of time in the background. And it's the Alpha 3 network, and they've internally codenamed it Fleming after Sir Alexander Fleming, who's a Scottish Nobel Prize winner from Ayrshire, where MaidSafe happens to be located. I wonder if that has anything to do with why they call it that. Anyway, he was the discoverer of penicillin. Major deal. So Ayrshire, penicillin, major shift. We think the SAFE network is going to be, maybe even comparable to that. That's my thought anyway. All right. So what is this Alpha 3 going to be, and how's it rolling out? Well, we're going to talk about the first chunk of rollout in the interview, and I'll get to that. I'll highlight that as we pass it. Overall, Alpha 3 is about security and scalability. It will be where community members and people who want to test can run nodes from home that will act as relay nodes. It's not the full data storage and everything, but they'll be relay nodes. So you'll be able to see fully encrypted transient data moving around the network. It won't mean anything to you other than the fact that you're participating in putting that infrastructure there, and we'll get to test it out. On that score, one of the key things that's going to be part of that release is being tested now. It was just recently released. It's the connection library. Peer-to-peer connections, especially when you need a really good stable network, is a big deal. And that's the Crust library, Connected Rust. It's written in the Rust programming language. It's how do you find and establish connections? And we talk about that with Nikita here in a minute. We'll play that interview. But there are other aspects. With this network running, you'll be able to actually see Parsec in action. Now, for those that aren't up with this, the last 2 episodes were about Parsec. And Parsec stands for it's an acronym, means Protocol for Asynchronous, Reliable, Secure, and Efficient Consensus. It's a decentralized consensus method. Kind of has similarities to Hashgraph and a couple of what IOTA uses, but those are closed source. This is open source, and it is really fast, and it can be used to secure all sorts of stuff. And that's we're going to be able to, with Alpha 3, we're going to be able to see that really in action. because you got to have a network to run that on that suits it. Anyway, now with any open network, since the SAFE network is going to be permissionless, how do you deal with the bad actors who come on and want to wreak havoc? Well, with Alpha 3, we'll see the rollout of node aging. This is a way that the network autonomously prioritizes nodes that have proven their trustworthiness over time, and that will create a defense against Sybil. There are other security things in there too, but that's a key one. Dynamic membership. What do you do when nodes are joining and leaving, and how do you keep track of that and keep the network from going into confusion? Well, that's dynamic membership is dealt with, and still maintaining consensus even with nodes shifting around. And then there's sharding. Oh boy, sharding is something that blockchains tend to have every transaction has to be agreed upon by everybody. Now, sharding is a means of splitting up the network in areas of responsibility to handle transactions, to handle things that need consensus by smaller, reliable sections of nodes that then can increase the throughput. And that's on the roadmaps of a number of different blockchain companies, but that's out a distance. And the difficulty with that really is very often that's like changing the wheels on your car while it's going down the road. Difficult, but good luck to them. It's a great thing. Disjoint sections is how MaidSafe has designed the SAFE network to handle from the very beginning, though it's had a little bit of adjustment to the structure. This is going to allow for consensus in very small sections, depending on what the network needs. Now, as those consensus groups come to conclusions, they're going to need to communicate with each other. How do you do that in a secure way? Secure messaging relay, because secure message relay is part of that. Anyway, there are probably other aspects that we could go into, but the Alpha 3 is being rolled out a little bit at a time, starting with the Crust layer. There's already been a test run on that, and there's going to be more coming up. And we'll find out about that right now. Let's welcome Nikita from MaidSafe, who came on to talk to us about it. All right, so we have Nikita with us. Nikita Baksalyar. Is that a fair enough pronunciation, Nikita?
Yeah, yes, of course, John, and thanks for having me.
Okay, good. Good. I try not to slaughter people's names too much. But all right, so you're from Russia, right? Tell us a little about yourself and how long you've been working with MaidSafe and so forth.
Yeah, of course. Yes, I am from Russia, but for the last couple of months, I've been working in the headquarters in Scotland. And I've been working with MaidSafe for 2 years to this date.
So you were working remotely and moved.
Yep.
Good. How do you like it there in Air?
It's absolutely great. So lots of sunshine. I can't.
Really?
Probably not so lots of sunshine, but recently it's been lots of sunshine. But for the most part, it's rainy and cloudy and windy, but it's fine.
That's what I understand of Scotland, right?
Yep. You have
well, cool.
A pretty good picture.
All right, good. So, you've been a developer for a while, right? You've programmed for how long?
Well, in Rust, I've been programming since the first days of the public release, so since 2015. But I actually have backgrounds in the general programming and computer science and all that stuff. Like, I've been programming for maybe 20 years or something since I was a kid.
Cool. So let's roll right on into, I will have mentioned it in the intro, but we're really having you on because you are really closely involved in the rollout and programming and testing of Crust. Now, give your description of that briefly, what Crust is.
Sure. So Crust is actually a library to enable decentralized connections over the internet. with usual libraries, like we couldn't use just direct TCP or UDP connections because they don't allow to enable like peer-to-peer connections and peer-to-peer networking, right? So that was actually the reason why we invented Crust. And it's not only about the peer-to-peer connections, it's also about the encryption because Crust as a library provides you with basic encryption primitives, and all the data that is sent over the wire is encrypted.
So we have encryption at the Crust layer as well. So, Crust stands for Connected Rust. It's written in the Rust programming language, right?
That's correct.
So I want to sidetrack and just talk about that for a moment, just to look at why is Rust the language that was chosen?
Yeah, sure. So before using Rust, before actually switching to Rust, MaidSafe used C++, and it was good enough for our purposes. But we found ourselves like while using C++, we spent more time actually dealing with bugs and language quirks rather than programming the application itself. So we decided to move the entire code base to Rust because Rust provides safety guarantees. And, well, basically, to put it simply, the compiler tells you if you have written something wrong in your code, as opposed to C++, where it's basically a programmer's responsibility to make the code right. And in Rust, the compiler hints you at which places you get wrong and how you should fix it.
So yeah, in a much earlier interview with Nick Lambert, he put it away, which I found was really good. He says C++ is an incredibly powerful tool, but like any sharp knife, it can cut you real easily. Crust has a little bit of Rust has a bit of a safety thing in the compiler where it says, yeah, this doesn't work. You got memory problems or whatnot, or you've got a bug here.
Yeah,
that
exactly.
It'll point out and get you, so you don't end up cutting yourself and having bugs in the code that are really difficult to find.
Yeah, because with Rust, we can focus on actually delivering the application and libraries code instead of focusing on fixing the memory bugs and all that.
Exactly. Okay, well, that applies to the whole architecture of the safe network. We're specifically talking about Crust, which is connected Rust, right? So it's a connection library in Rust, as you said. So let me ask you this. Are there no peer-to-peer connection libraries out there?
Probably there are lots of them now. Maybe not lots of them, but at least there should be several libraries which are written in Rust. But at that time, like when we started developing Crust in year 2014 or 2015, there were no suitable libraries, and especially no libraries written in Rust. So that was one of the reasons why we decided to go for our own library. And then, apart from that, the other libraries that were there, like probably libraries written in C++, they didn't suit us, not only because they were written in a different language, but also because they didn't suit our exact needs, which are like enabling P2P connections using NAT traversal and also enabling the encrypted connections. So it's like Crust as a library provides not only the connections, but also like it uses multiple NAT traversal techniques. It uses encryption and all that stuff.
Okay, well, for those who don't understand immediately what you're talking about when we say NAT traversal, I want to cover that a little bit. I'm going to link to one of the Safe Network School podcasts I did called Connecting Them All. I don't remember the number. Most of what is covered there is still applicable. But in a nutshell, what I really spotted in sorting that out to put that podcast together and with the interview that I had at the time is it's really easy to overlook the fact that connecting all of these computers together, it just even not on this peer-to-peer is quite something. You know, you've got to go through different kinds of protocols and connections and hardware. And it's amazing that everything connects together as well as it does. But when you go to, okay, well, we want a whole network of computers that are linking peer-to-peer and not going through central thing, that gets a lot more complicated. Is that statement pretty accurate? Does that kind of set the stage for where we're going here?
Yes, exactly. It is a really important and a complicated thing because Crust serves as the foundation of the SAFE network as a whole, because without the ability to connect computers directly, we wouldn't have SAFE network in the first place.
Right. So could you give us a little bit of description of what that you say NAT traversal. Could you tell us what that means and fill it in for those of us who don't have a real good idea?
It all boils down to the current architecture of Internet, which started more than 40 years ago. And when it was started, no one actually thought that it would get that big. The numbers of users of Internet now is just huge. And when it started, it was just a couple of universities and some government organizations. And really, there were like probably less than 1,000 users back then. And when it was started, it was architected in a way that the IP version 4, as we know it, there are 4.3 billion possible addresses. And back then, 40 years ago, everyone thought that like we will never get to that number. So that should probably be more than enough. And 30 years later, we are finding ourselves in a situation when basically there are not enough IP addresses for all users that want to connect to the internet, right?
Right.
So the solution that was found is to basically put multiple users and multiple networks behind the NATs, which stand for like Network Address Translator. What it basically means and how it works is the concept is pretty simple. So imagine if you have your own local network or some corporate network where you have, like, say, 5 computers or 1 computer and 4 mobile phones. So it's your like family home network. And basically what was thought that not every single computer needs to have its own separate address. We would do just fine with one public address, which would serve as the entry point for all the network devices from your local network. So basically, what it means is that when you connect to the internet, the only device that will have the real IP address is your router. And you connect to the router, which assigns you some local IP addresses like 192.0.0.1, for example.
Your router keeps track of the devices behind it, but
Yes.
it's the internet just recognizes the one device.
Yeah, exactly.
Yeah, okay.
Yeah, and well, it works just because like our understanding of internet has shifted because, well, basically currently how we use internet is it almost became synonymous with web, right? So when people speak about internet, they think about the web browsers and like visiting the web pages and all that, right? They don't think about like a huge interconnected network of billions of computers.
Right. So basically we have, because there's a limited address space, all sorts of other solutions have come up. Now, there's another version, IPv6, which gives plenty of address spaces, but it's really been hard to get that adopted because of the other existing workaround. Isn't that what's going on?
Yes, exactly. And it's really hard because just to switch to IP version 6, you will have to invest huge amounts of money because there are lots of existing networks and it's just a huge existing infrastructure that you will need to replace almost entirely. And it will be very complicated. And it also doesn't solve the problem of NATs because with IPv6, you will still need NATs because, for example, for corporate networks, you wouldn't even want to give each of the computers in the private network a global address, right? Because of the security reasons or for any other reason. Like if you want to secure the data that is stored in your private network, you wouldn't want to put those computers in the global network, right?
So even a full change over to IPv6 would not really handle the situation completely. So cool. So we've got connection library that we call Crust. Why is it necessary to have this protocol? What does Crust do that nothing else does?
Well, it's because of this very specific reason that we want users to connect directly between themselves. So, for example, like I said, currently our model of the internet in our minds is that you just request some data from a web server, you get it back, and you send it back to the same web server. So really, we can't we don't imagine that we don't imagine it as, for example, some web server contacts us or our computer. It's just the client and server module. So we want to get rid of that in the first place to be able to communicate directly between users so that it would be possible not only to contact some computer in the internet, but also for some other computer on the internet to contact us without us requesting it first, if that makes sense.
With the peer-to-peer model that the SAFE network requires, let me ramble here and see if I'm getting the picture or putting it across. Basically, we're looking at far more interconnections directly from computer to computer that need to be established and maintained. A lot of those are going to be behind network address translations. In other words, you've got your route. People are behind routers, and how do computers reach past that router to find you, and vice versa. And so, Crust is one of the key designs is to bypass those barriers, and there are various means of doing that. Is that correct?
That is correct. Yes. Well, basically, if you really want to have peer-to-peer communications, a user can always try to forward their port by going into the dashboard of their router and manually forwarding the port, because this problem is not new at all, right? So like the peer-to-peer communications is not a new problem because, for example, the voice over IP or VoIP companies are struggling with that too, because people want to have calls bypassing the service, and people want to have calls just by directly communicating because it is faster. And with the direct communications, you have smaller latency. And so the problem of NATs and NAT traversal is not unique, and it's not only pertain to like file transfer or P2P networks. It's also widely recognized in the P2P in the VoIP world.
Okay, so we get around to Crust. Why? What is it that Crust does that doesn't happen elsewhere? Why do we have to have this library specifically? Aside from the fact that it is open source and we plan for lots of people to use it, right? Why did we have to have it, and what is it doing that isn't otherwise attainable?
Yeah, that's right. So it is currently possible to bypass NATs by manually forwarding your port numbers, but it's not very user-friendly, right? And it's not always possible to do in the first place. So, for example, you don't want to ask your users to do this port forwarding thing. You would just want to enable the direct connections, right?
I would have trouble figuring out how to do that.
Yeah,
it would
exactly.
take time, and I would just go, never mind.
Yeah. You don't want to go for an extra step just to.
This is not the SAFE network is not designed to be a network of geeks. It's designed to be accessible by everybody quite easily. So, Crust has got to be designed to just handle all of that under the hood. Is that safe to say? Finding ways around the difficulties of making connections and automating it in this library.
Exactly, because all you need to do while using Crust as a library, all you need to know is just the Actually, you don't need to know a lot, because Crust as a library handles all of that in the background. It gives you the connection information, and you send that connection information to your peer. And by using that connection information that you got from someone else, you just call the connect function, and Crust does all in the background. So just by having the string that the other person passed to you, you can connect to them directly. So it's pretty simple.
There's a lot of interconnection where, somebody else knows how to make the connection, so they pass that around to those that need it.
Yeah, exactly. So all of the complexity in Crust goes under the hood, because on the surface, from the programming interface standpoint, it's a pretty simple library.
Cool. Now, where are we at in the development of Crust? We just completed a short period of public testing where forum members, at least people who had trust level 1 on the forum, could download and run a test. How did that go? What was learned from that?
Yeah, the test went actually very well because before the first public test, we really didn't have a lot of data because we tested Crust mostly internally, right, in the company for the people who work in the office or remotely. And that's not a lot of data because some people work in the same office and using the same internal network and actually have the same IP address. So that doesn't really give you a lot of information about which setups you can find in the wild. So that was really useful in the sense that we collected a lot of information, for example, about how many people have UPnP enabled in their routers and how many people it actually works for. So that's a very useful data point because we can use that in making decisions for Crust in the future.
So when is the next test phase rolling out, and why might people want to participate in this? Aside from the great crowd on the forum who are all behind us already, isn't this something that other developers might find interesting to participate in because of their own peer-to-peer projects? Crust being open source, right?
Yes, it is actually licensed under the It has a dual license. It is licensed under BSD and MIT terms, so it's a very permissive license, and it is completely open source. And yeah, answering the first part of your question, the second phase of test is scheduled to be run this week, and we will collect a little bit more data this time, because this time we will attempt to use direct connections. And for the latter part of your question about why would people want to participate in this test, it's actually answering this question for myself, why would I have wanted to participate in that as a developer? I have a pretty straightforward answer because it's a chance to test something that can make history, right? It's basically as if you have participated in the early days of internet or in the early days of Bitcoin, where you can, when there is not a lot of users and when we want to test something that can probably be very big in the future. And to become an early adopter is a big opportunity, right?
Right. Thank you. I'm sorry. I tend to ask multiple questions at the same time, so I appreciate you parsing that out. But that actually brings up a really good point in terms of to highlight that what's being done with Crust here is something that hasn't been being done. It's being done because it's necessary to actually implement the SAFE network. I mean, this has been known all along that this phase of development would have to come, but it is also a completely different paradigm of connecting peer-to-peer networks that'll apply not just to the SAFE network, but to others. Is that a fair statement?
I think so. It's very important to understand why would someone want to use Crust. I can give you one example. Recently, MaidSafe released Parsec, which is a consensus algorithm, right? And there are lots of blog posts and articles about that and what it actually allows to do. So I wouldn't repeat that, but I would just say one thing is that Parsec by itself doesn't know anything about the networking. So it is completely abstract in that sense. So it is up to a developer how to send and receive the data over the network. What Parsec is concerned about is the roads and basically basic building primitives of Parsec, and how do you transfer them over the network is basically...
That's not the subject of the protocol itself, yeah.
Exactly. So that role is served by Crust, or can be served by Crust, because what it allows you to do is is not to be concerned about the networking at all, but just to send the data in a peer-to-peer fashion, right? So you don't need to be concerned about the things like NAT reversal or how to actually send this data to other peer over the wire or how to encrypt it. So basically, you can be focused only on actually using this data and sending this data and receiving this data, and all of the other concerns are like the Crust's concerns.
Right. So Crust handles all of that behind the scenes of not only finding and connecting the network of peer-to-peer computers, but also it handles the encryption level of all of that. So you already have a security feature built into Crust itself.
Yeah.
So anybody who wants to participate in the testing, whether they're developers or just community members or interested or just seems like fun, what would they have to do to participate?
Well, the first thing that they will need to do is to register on the Safe Network forum and achieve the trust level 1. And that is required because we don't want to handle malice and spam in this test. It's out of the scope of this test. So we decided to go with the option that we used for Alpha 2, basically requiring some minimal level of trust. And well, actually, it is pretty simple to achieve that level of trust. You just need to register on the forum, read it for a little while, leave some messages perhaps, and you will achieve that level of trust pretty quick. So from that standpoint, it's not very complicated.
All right, and what's the experience of doing the test? I participated some in this last one, but can you describe how easy is it? What's the experience of it?
Yeah, it's pretty easy. So you just need to download the client software, just unzip it, basically. It is a complete program, complete binary that you run from your computer, and it will connect to the proxy and will start seeking for other people in the network. And when it finds someone that you can connect to, it will proceed with the direct connection, and it will just report to you whether the connection was successful or not.
And you can watch all the activity roll by on your terminal screen. So that's kind of fun.
That's actually not the most fun part of it, because if you go to the dashboard, you can actually see all the connections that have been made between the users. And if you just look at the list of countries of people that are participating in this test, it becomes you can feel it's like almost the early days of internet when it's magic when you connect to people from China or from Argentina.
And they're all interconnecting. Yeah, that is kind of cool. Anything else other folks ought to know about this?
Yes. So, well, what I can highlight is that with this test, we will get a higher number of successful connections, because for the first test, what we really attempted to do is to count successful connections as only like if we could do the one specific net traversal technique that is called hole punching. And now, when we enabled the direct connections, that will add another technique to our arsenal, and it will allow to have a higher number of successful connections, so that it will be more fun in this sense that you will see less failures.
Cool. Oh, yeah, that is something that we should just mention, that the from my understanding, and correct me if I'm wrong, the neat thing about what Crust does, it's a hierarchy of, well, a straight connection, that's usual, is the first thing attempted. Well, that doesn't work. Then there's several different layers of more and more involved schemes of getting past not having a connection, right?
That's correct.
Yeah, and so we rolled out the first one. Now you're going to start adding the second, and then there's several layers of that should end up in a really robust connection protocol.
That's correct. And well, in this, the thing is, in this test, we attempt to use all techniques that are available, and we can see the data points separately. So, for example, we can see if the direct connection has succeeded, and if like the NAT traversal has succeeded. And that is really important to us, just to distinguish, just to tell which techniques are actually work better and which are not that useful. And in the real world scenario, like when you would use Crust for your P2P network, it will just return the first connection that has succeeded. So, for example, if you connected to someone else using like hole punching and direct connections, it will be like the first one that was successful.
I got it. Well, all right, Nikita, thank you very much for stopping in, and we'll see you around on the forum.
Thanks a lot.
Say hello to everybody there in at least temporarily sunny Scotland.
Okay.